This is the fifth video in the series on coordinate geometry, and it deals with some circle problems. Okay, let's consider this problem here. Determine whether the point -2, 3 lies inside or outside the circle whose equation is x plus 3 squared plus y minus 1 squared equals 4. Now, this equation, this circle has centre -3, 1 and radius 2. That's because it's 4 is 2 squared. And in order to determine whether or not the point is inside or outside, we would look at the circle with centre C, which is -3, 1, and if the point P -2, 3 is outside, we would see the line CP would be greater than the radius. However, if the point P is inside, then the line CP would be less than the radius. So to find CP, we just need to find the distance, and then that is using the formula x1 minus x2 squared plus y1 minus y2 squared, in the square root. And in this case, we have this equals the square root of x1 could be -2 minus -3, so that's x1, that's x2, plus y1 minus y2, we have 3 minus 1 squared. So -2 minus -3 is 3 minus 2, that's 1 squared, which is 1, plus 3 minus 1 is 2 squared, which is 4. So square root of 1 plus 4, square root of 5. So CP is √5. The radius is 2. So CP is greater, √5 is greater than 2. So CP is greater than the radius. So P is outside the circle. Now we come to problems involving lines and circles. Now if we have a circle and a line, the line might miss the circle entirely like that. It may intersect in 2 places like that, or it may touch the circle at one point like that and be a tangent to the circle. So that is a tangent. It may is so the line may have no intersections with the circle like that one, intersect once like the tangent, or intersect twice like that one. The way to determine which one you have is by solving the equation of the line and circle simultaneously, which will give you a quadratic equation, and then testing to see whether there are 1, 2 or no solutions by investigating the discriminant. Let's consider this problem here. Show that 2y plus x equals 18 is a tangent to the circle x minus 2 squared plus y minus 3 squared equals 20. So what we need to do then is equate these two equations and solve them simultaneously. And when we have a quadratic and a linear equation like this, we substitute for one of the variables into the quadratic. So probably easiest here to say x from equation 2, x is 18 minus 2y, so substituting that into equation 1, 2 in 1, we will get 18 minus 2y minus 2 equals plus, I should say, y minus 3 squared, should have a square there, equals 20. So that gives us 16 minus 2y squared plus y minus 3 squared is 20. And expanding this, we'll have 64. Sorry, that's not 64, is it? 16 squared is 256. Twice the product is minus 64y plus 4y squared plus, and expanding the second term, y squared minus 6y plus 9 equals 20. Collecting terms, we have 5y squared minus 64 minus 6, so that's minus 70y. 256 plus 9 is 265, and subtract 20 from both sides, that's 245 equals 0. Divide by 5, y squared minus 14y plus 49 I should say, 49 equals 0. And now we calculate the discriminant. B squared minus 4ac is equal to 14 squared minus 4 times minus 14 times 49. Correction there, of course, it's minus 14 squared, b squared, minus 4 times a, which is 1, times 49, which equals 196 minus 196, which is 0. And when we have discriminant equals 0, we have equal solutions, or one solution to the quadratic. So therefore the line is a tangent. 2y plus x equals 18 is a tangent. Now it's always useful to draw a diagram when trying to solve these problems. Here we have a circle, and the line y equals x plus 3 intersecting at A and B. We have got to show that AB is a diameter, so we need to show that the centre of the circle is on the line. So the thing to do is to find the coordinates of A and B, and then we can find the midpoint of AB, and if the midpoint of AB is the centre of the circle, then AB will be a diameter. So to find A and B, we would solve simultaneously the equation of the circle and the line. So y equals x plus 3, so we substitute 2 in 1. So we have x minus 2 squared plus y is x plus 3 minus 5 squared is 18. So x minus 2 squared plus x, and 3 minus 5 is minus 2 squared is 18. And so we can see here this is a simple equation to solve, because that's 2x minus 2 squared is 18, and divide by 2, x minus 2 squared equals 9. We can now just take the square root of both sides, and we'll get x minus 2 equals 3, or x minus 2 equals minus 3. So x is 5, or x is -1. And substituting back into 2, if x is 5, y is 8. 5 plus 3. And if x is -1, y is -1 plus 3, which is 2. So A is 5, 8, and B is -1, 2. And so the midpoint of AB is 5 plus -1 over 2, 8 plus 2 over 2, which is 5 minus 1 is 4 over 2, 2, 8 plus 2 is 10 over 2, which is 5. And if we look at the equation of the circle again, x minus 2 squared plus y minus 5 squared means that the centre is 2, 5. So centre is 2, 5, which is the midpoint, hence AB is a diameter. When solving problems involving circles, you may need to be aware of the theorems in circles, which you should know. Quickly run through those. If you have a circle, the tangent to any point and the radius are at right angles. So the tangent is perpendicular to the radius. Secondly, tangents from a common point are equal. So if this is P, and that's A, and that's B, then we have AP equals AB, PB, I should say, or BP. Thirdly, the angle in a semicircle is a right angle. Fourth, the perpendicular bisector of a chord passes through the centre. Conversely, if a line passes through the centre at right angles, it bisects the chord. And if a line going through the centre bisects a chord, then it does so at right angles. Then we have the angle at the centre here is twice that at the circumference, and angles in the same sector, which are subtended by a chord, are equal. So any of those theorems which you should know might be needed in solving problems involving circles. That's the end of the video on circle problems. Now return to Study Smart to practice.